About store procedures. Store procedures, are basically the capability of databases for you to program right inside of the environment of the database, right, where you are closest to the data set, right? It's a database. It's functions that can and procedures that can run right inside of the database, right? So it's very, very powerful. They are the closest to the server, right? And they can access the data right away. Now there are some limitations that there's a completely new environment that you need to learn, a completely new language. There's a maintenance that you have to now maintain all this new source material. Oftentimes the tools that are used for building or coding perhaps are not as sophisticated as other environments or IDEs that have all sorts of refactoring mechanisms and whatnot. Obviously, you might not have the same sophisticated reusability mechanisms that you might have in full object-oriented technologies and whatnot. So there are pros and cons. Certainly for performance, this is as fast as you could possibly be. Right, you're right there running in the database. Although oftentimes these stored procedures can be fairly expensive, right? And certainly any CPU cycles that you're taking away from data access because you have to run these procedures, right? There's a game that you need to play on performance, right? If depending on how many calls and if your database is mostly transactional or reading the data, if it's a read-only operations, then perhaps you might want to have stored procedures running elsewhere, right? That don't necessarily are running in the same place. These could be fairly expensive, taking away the CPU time that the database server might be used for, just responding to query, right? So we have to be careful with having long-running stored procedures that might block the database, right? So there's the pros and cons with going, right. Certainly, you can oftentimes you can when you have certain operations that you can't very well implement with plain old SQL, right, with select, insert, update, and delete. Right? Oftentimes, a better option to just implement the stored procedure. So you can use procedural, sequential, do this and this, and step 1, 2, 3. SQL is it's a declarative language, right? You're specifying, you're declaring the things that you want to happen, but it doesn't specify the procedures in which that should happen. Instead, you're letting the database compile these things, right, and translate it into a plan of execution. Whereas the store procedure, you're specifying exactly what you want to happen, right, in the order in which you want. You can have loops and if statements and everything you would expect in a full-blown programming language. Obviously you have the faster network performance as opposed to if you go with other solutions such as JDBC or .NET, or if you're outside of the server, you have to have a network connection, right? So now you're certainly you're not going to be as fast, if you're running outside, right? Oftentimes there's a mix and match of both technologies where you might have certain store procedures running or compiled and ready to run in the inside of the database, but you're executing it and running it from outside, from JDBC or Java or C#, and you are sending commands to execute certain stored procedures at a particular time in a particular sequence. Obviously, you can implement fairly complex security measures that if you are in a particular role, then I won't allow you to insert, update, delete certain things, right? I'll make sure that you have the correct privileges and you're allowed to do certain things, right? So oftentimes we wrap fairly complex logic in these store procedures, right, to make sure that the database is always accessed through a store procedure and never directly with a low-level SQL statement, right? Where we might make all the tables unavailable, so nobody can do a select statement or insert or update, right? Only a very select few folks might have that privilege, right? They always have to go through a store procedure, and the store procedure can then verify your authenticity, who you are, can you do these things, right? And then execute the queries for you. Maybe clean up the results and then give you a meaningful result set that you can use, right? So yeah, store procedure can be fairly sophisticated. and very, very powerful. Again, the cons is that this is yet a new technology stack that you have to maintain, right? That you have to learn and whatnot. Also complicates migration, right? Once you start using a store procedure that certain features that are specific to your vendor, right? Now you become dependent on those features for that particular vendor. It makes it so much harder, to go from MySQL down to SQL Server, or move any of that data outside of that particular vendor, right? And vendors will try to lure you into using those features, and marketing, and how awesome these new features and new functions and new transformations, and they'll try to lure you in to make you a repeat buyer, right? So you'll be a long-term client of them, right? But again, it depends how married your organization is to specific vendor stack and whatnot. Yeah, but it does happen, right? That folks just go from one stack to another, and so migration is a serious concern. Right, you're adding burden to the database, right? To run these databases, these queries, yet another language to learn. Now there are three types of executable code that we're going to consider, right? There's triggers, functions, and procedures, right? They all entail writing code, right? With for loops and if statements and whatnot. Yes, usually they also entail doing inserts and updates and deletes inside of the store procedure, right? But depending how you use them, and depending on when do they run and how do they run, they fall into these three different buckets, right? So we have the triggers are somewhat of the more common ones, right? The triggers are executable code that will run when some event occurs, right? They're not meant for you to execute them from the console. Instead, you say, hey, if this event occurs, I want you to run, right? And usually it's based on maybe you want to listen for incoming inserts or incoming updates, right? And so you can run these store procedures to look at those inserts, right? Look at all those updates. Maybe the insert comes in and the data is not good, right? And maybe you want to clean up the data, right? Maybe you want to parse the incoming fields and do some some pre-processing before letting the insert actually go into the database, okay? Or somebody's updating some information and you want to verify that those updates are valid, right? Certainly you can have a lot of constraints on the create statement, but there might be constraints that are not enforceable through foreign keys, primary keys, and inside of a create table statement. Instead, you want to programmatically choose, right, certain things that if these conditions are correct, yes, I will let you update, right? Or I'll massage the data to make sure that the update is correct, right? So you can you can be more powerful like that, right? So yeah, they can change data. They're not meant to return data. They're not meant for you to run the query, right, and then comes back with some calculated value. Instead, they're meant for kind of intercepting some certain events, and then either letting it go or not, or massaging inserting their way into the data manipulation. Yeah, so they're event driven. The other one is functions. Very much like you can call a function, you can pass parameters, right? They're meant to calculate data, right, as part of some parameters, and usually are meant to be invoked, right, as part of some query, where you're doing some select or some insert or update, and one of the fields might be a computed value, based on the parameters that you're inserting or the parameters that you're selecting, right? You can pass these parameters to a function. The function can run, execute the code, and then come back with a result. That result might be a single value, a single integer, a single string, or it could be a collection of values that you can then use in an in statement, right? So they're meant to be part of a statement, right? And with parameters in the outer select statement or whatnot. And then there's procedures, right? That are meant that you can run right from the command line, right? That's again, they're almost like functions that you can, but they're meant to be run from the command line, not from within a statement, right? You can pass the parameters, it does some execution, and it does whatever, inserts, updates, deletes, from within the procedure, right? If you find yourself, especially system admins will have lots of these procedures hanging around that allow you to, to initialize the database, clean up, and do a lot of administrative things. Okay. They return data, well, if you want them. Now, they all share the same programming language, right? The same, the same functionality that we're gonna look at. It depends how then you decide to use that code, right? How you want it to be invoked. If you want it to be invoked inside of a function, instead of a statement, or do you want it to be triggered and run from when an event occurs? But otherwise, the coding is identical to all three. So here's one of the simplest procedures. They're all created using the create statement. You create procedure and then the name of the function, or procedure, sorry. You can add a comment. There's the same comments syntax that you can add even your select statements, your inserts. You can add these comments. And then you have a begin and an end. And then inside the begin and end, you can have if statements, variables, for loops. You can have also embedded select statements, insert updates in there. So you can iterate and say, well, okay, I want to insert 10 records, right? And here are the values, and it'll iterate, inserting all those 10 records, right? Or you can do queries. You can also do select statements. Again, all these queries, all these inserts, updates, selects are meant to be executed in the future, right? When you run the store procedure, they're not meant to be executed right away. Okay, and so this select will only run when you actually run hello world. When you run hello world, it'll run the select, as if you would have typed select hello world in your command line, right? And so it'll come back, it'll print out on the command on the console. It'll print out whatever what it would have written if you would have written select hello world at the command line. You can so this is the generic syntax for creating. Now, because you have now, and as you're typing in the console, you have these select statements. The database needs to understand that you're either in a mode. How should I interpret what you're typing? Are you telling me to select that right now? Should I do this right now, or is this postponed to later? Right. So it needs a mechanism that allows it to let you go back in and out, right, in the modality on whether you are programming or are you actually interacting and telling me to do something right now. So for this, the databases will have delimiters that will allow it to go in and out of this modality on whether you're programming, right, or you're interacting with the console right away. You can choose whatever delimiter you want. Common ones are // and you can specify using the keyword delimiter // or when you start // you're telling, hey, I am entering the programming mode. The following are statements creating a statement, a store procedure, which I want to execute later. And then you can leave that modality by typing the same delimiter again. Also, there are slight differences between the vendors on how these are created or how they're invoked. If you're using MySQL, we use the keyword call. Instead of you're using a Microsoft SQL Server, right? Then you would use execute, right, or exec. So again, depending which vendor you're end up using, you'll need to read a little bit about the documentation on what the syntax is. Slightly different, okay? And we'll point them out as we go. You can also alter a procedure, right? And you can so that you can either rewrite or redefine it. Usually, they'll give you some IDE, right, where the procedure are listed on the left-hand side, and you can double-click on that store procedure, and it gives you an IDE and an editor where you can edit it. You can also alter from the command line, alter store procedure, and then you can type in the new declaration. But more typically, you'll be editing in an IDE. Or you can drop the store procedure, if it exists, and this is very common, when you're reestablishing or recreating a database, right? You'll have a SQL scripts that will have lots of drops at the beginning, where you drop all the tables, you drop all the data, right? You recreate them in the correct order, right? Notice that the we'll see a little later that the order in which the tables are created and the stored procedures are created matters, especially if you have tables that depend on other tables, right? That have foreign keys on tables that it assumes already exist, right? They need to be declared earlier in the script, otherwise the later tables are going to fail, right? Saying, hey, I'm declaring this foreign key on a table that doesn't exist, right? So you have to be careful, right? Typically, you'll have a SQL script that drops everything and recreates everything from scratch and then imports some initial data. So same thing, you'll have a drop all the procedures so you can recreate them from scratch. And usually we add this if exists at the end of all these drop statements, right? Otherwise, many of these drop downs will fail if it's the very first time you call this, right? It says, you asked me to drop something that doesn't exist. Right? You'll have lots and lots of exceptions. Yes, this is the syntax for altering an existing procedure, where you can give it you can redefine it by copying and pasting or retyping the declaration of the stored procedure. But again, more commonly, you will be editing this in an IDE, and then the IDE will be sending this command, right? We'll drop the old statement, and then we'll execute an alter stored procedure for you, right? The IDE will do this for you. Local variables, you can declare variables like in any function or any executable code. Inside of the begin and end block, any variables that you declare are considered to be local variables, right? That are meant to die at the end of the end statement, right? So there's you use the declare function keyword, the name of the variable, the data type, integer, varchar, double, whatnot, right? And you also give it a default value and also a comment at the end, right? To document the use of that variable. Right. So the returning values. So some of these return values mean something depending on whether this is a stored procedure that is meant to be executed at the command line, or this is a function that is meant to be executed from the statement. Or it's a trigger which is not meant to return anything, right? So the store procedure will return usually whatever you have in the return keyword, right? Return 1, 2, 3. But meantime, right, while it's going, you can see the intermediate results, right, of executing the statement if you have any select statements in there. So here, for instance, we are selecting hello world, and then at the end we're returning 1, 2, 3. We are invoking it using a call. We're using a call, and then we can store the value in a global variable over here, return value, right? And then you can see what the value of that return value is. 1, 2, 3 was returned, and you can see the store procedure printing the hello world in between while it was executing, and then the return value was being assigned to this session variable return value. Here again, we did the same thing, but we did 2 selects, the hello world and the goodbye, and declaring the value as a result of invoking that store procedure. Here's a couple more using a full select statement with the from and a where. Yes. Oh, it's using the SQL's MySQL execution. You can use either call or execute. So if it's MySQL, if you're using Microsoft SQL Server, it's exec. If you're using MySQL, it's call. So depending on the vendor, the keyword is different, but it's the same thing. It executes the procedure. Here we have another select statement doing that query and printing out the result on the console. We're not assigning it to anywhere. We could assign it inside of a stored procedure if you want to use that result set, in a later execution. Maybe we want to iterate over those rows, right? Programmatically, sequentially. Parameters. We can pass also parameters, in parentheses, and we can give it some optional keywords that specify whether the value that we're passing is either by reference or is it a pass by value. Okay, if you've done C or C++, right, that you can pass values by either one, as a pass by reference or pass by value. where either the value is either copied onto the remote function, right, that you're calling, or whether you're passing the actual reference of the value that you're passing, right? And usually the reason why you do one or the other is whether you want to give that function the capability of updating or manipulating the original variable that was passed in. Okay, in SQL, you can have an additional type. Okay, you have three actually, not just pass by value and pass by reference, but you have in, out, and in, out. Right? So each one has its own meaning. By default, it's in, meaning you're passing me a value, right? That I'm going to be able to read. I'm going to be able to read this value, but I won't be able to modify it. Right? It's kind of like pass by value, right? You're copying the value. I have a local copy now of that variable in my store procedure, and I cannot change the original value that you pass me. Yes. Whereas out means that this is a value that was specifically created locally in the store procedure, and I'm returning it to you, right? Almost like almost as if it were a return value, right? That you can assign it to. Instead, you're passing me a value, right? That I can change from inside, right? I'm passing it to you. Now, if you're doing both in and out, this is the common, pass by reference, right? Where you're passing it to me, I can change it, and then I can give it back to you changed from within the store procedure. So let's look at a couple examples. Here we are declaring passing the value 10, right? So it's passed by value. So I have a copy of this now in var1 instead of the store procedure, and I can add to it, and then print out the result of adding 2 to it, right? Now the value that I'm passing is passed by value. If that were being stored in a variable, I wouldn't be able to modify that variable, right? Or I can change this, right? I can change the value of something and pass it to you as a result, right? Not only can I be assigned, not only can I return something and then assign a value to some variable, but I can also send you new variables that I can calculate internally inside of the store procedure using the out keyword. Or it could be in out. This is like a pass by reference, right? You pass me a variable, I can modify internally, and when you get it back on the other side from the caller, that value of that variable has changed from within the internal procedure. So here's an example where we are using both in out, and we are initializing the increment to be 10. We pass it to the procedure P, right? And internally, now the incremental parameter over there has a reference to the original variable. It changes it, adds 1 to it, and when it comes back, and we see that notice that we have not assigned increment to P, right? We haven't assigned increment is equal to P or whatever returns here, right? So it has been changed from internally from the inside the store procedure. So we got variables. Yeah, so we can as we saw earlier, we can declare yes. Oh, you can pass any number. Oh yeah, like comma separated. Yep. And each one can be its own in out. Each one can have its individual keyword. So we can declare variables either inside of the store procedure or outside, but typically inside of the store procedure. Declare them as integers, varchar, timestamps, give them default values, and then you can use them inside of a set or selects. So here's a couple examples where we're declaring several values for a, several, an integer, a string, a couple of timestamps, right? And internally we are inserting values into a particular table. Declaring the value of a string and then using that as to concatenate and create a new value for retrieving from a particular table, right? So instead of just using the select statement, you can prepend it with some logic before running the select statement. Here's another example where we are declaring the value. Here we're initializing var2 to be equal to 1. Now notice it's being declared outside of the stored procedure. Right, this var2 over here at var2 is being declared outside of the stored procedure, so it's a global variable, visible to everybody. And we run the procedure. Now inside we are declaring a brand new variable called var2. Notice that it doesn't have the @ sign, so it's a when it has the @ is referred to as like a session variable that has a value as long as the session is alive, and it's available anywhere in wherever you refer to it. Kind of like a global variable. And so here we're saying var2, we're adding to. We're doing the same thing with the session variable, which is globally accessible, and we are printing out both values. Now the variable var2 that has been declared locally does not have side effects. Right? It's a local variable. Right? It's not available anywhere else, only inside of that function. So if we call that repeatedly, notice that var2 is always 2. Right, because once we reach the end, that var2 local variable is thrown away. Right, whereas the @var2, it's a session variable and it's a global variable and alive as long as the session you're logged into the database. Let's look at conditionals. Like any programming language, you would expect that you have branching, right? Or you can run different logic and different executions based on some predicates. And stored procedures is no different. Here we can have the if and if that we can decide to do this particular select statement or that other particular select statement, right? Depending maybe on the role that your particular role. If you're an admin or if you're a reviewer or a user or a developer, depending on your role, right? You might do certain inserts, certain updates, based, driven by your particular role. And you can encapsulate that entire logic inside of a stored procedure. You have other syntax. You have instead of if statements, where you can have nested if statement, you can have also case. You have two versions of case. This one, the simpler one, checks to see the value of a single variable compared to many outcomes, right? Any number of enumerated possible values. So checking variable against 0, 1, and whatnot, and then it inserts into different tables depending on the case. Or a more powerful version of this, where each individual when can have each individual and separate predicate. Right here, the predicates are always checking against a variable, but really they're independent of each other. Right, they can have their own predicates checking different variables. They don't have to be checking against a variable. Now, if you're checking against the same variable always, then perhaps this syntax is a little easier. Right? If instead the predicates are mutually exclusive and the predicates can be different, more powerful, then you can use this syntax instead. You can also loop, right? And you have three types of loop. You have while do, loop, and repeat until. And so here we're setting a local variable 1 to be equal to 0, and we're using the while and while. And as we're iterating over this, right, and we are incrementing the variable 1, as long as it's less than some variable that we pass in as an argument, right, it's inserting a whole bunch of data, right? This would be great for creating lots of dummy data or test data that you might want to use for performance reasons, right? Where you can create hundreds or thousands of records, right, with some random data that you can then run some performance against it, right? Or that insert could be much more sophisticated with all sorts of if statements, right, and case and whatnot, and then generate some meaningful data. There's also repeat until. So this is the while do or do while, right, where you at least are executing the repeat at least once. Right? So this is just iterating over several times. Or you can label. You can create labels and loops, right, that allow you to go back to the a label, and you can have multiple labels, right? And depending on certain outcomes, right, you can jump to different, almost like a go-to, but not quite, right? All right, let's talk about triggers.